In this video, we will be continuing our lesson on operations of functions. So basically this is a continuation of our concept. The video that we've recently had was all about operations on functions. This time, we'll be having another seat work to answer, which will compose of 22 items in total. So let's start. Instructions say, perform the indicated operations. Let's start with number 1. So we're called to find g of 3 added by or added with f of 3. So what we have to do is we have to find, so we know that a is equivalent to 3 for us. So we have to find what g sub a is and what f sub a is. For g sub a, we'll be replacing a to 3, so we'll be finding g sub 3, and the other will be finding f sub 3. Let's make our pen thinner so that our solutions will fit. So g of, you have to make the eraser that way. Okay, g of 3 is equivalent to, replace a with 3, so 3 raised to 3 plus 5 times 3 raised to 2. G of 3 is equivalent to 9 times 3, 27, plus 5 times 9. So 45 plus 27 is 72. 72 there. Alright, let's solve for f sub 3. F sub 3 is equivalent to 2 times 3 plus 4, which is basically 10. So f sub 3 is equal to 10. 6 plus 4 is 10. It's not our final answer yet, so we won't box it. My mistake. So find g of 3 plus f of 3. Basically, we'll add them. So 72 plus 10. And I suppose that you already know where this is going. So we have 82. This is our final answer. Alright, let's move to number 2. So f of x, g of x, whereas it's not a this time we have x. X is equivalent to negative 4. So let's solve for f of x, which is, in other words, f of negative 4, such that x is equivalent to negative 4. So negative 3x raised to 2 plus 3x. F of negative 4 is equivalent to negative 4 times negative 4 is 16, positive 16. Negative 3 times positive 16 is negative 48, and 3 times negative 4 is negative 12. So when you combine negative 48 and negative 12, you get negative 60. Let's make this smaller. Oops, my mistake. There you go. Let's find g of x, which is, in other words, g of negative 4. It's equivalent to 2 times negative 4 plus 5. G of negative 4, negative 8 plus 5 is negative 3. So our operation in this problem is division. So f of negative 4, negative 60 divided by negative 3. Our answer is positive 20. So let's recall our lesson with negative and positive values. When we divide or multiply both negative values, our answer, whether our answer is a product or a quotient, our answer will be a positive integer. So there you go. Box looks weird, but I hope it does work. Let's move to number 3. in other words, what we're trying to find here is we just apply distributive property. uh, so g of 9 plus f of 9. In that case, we know that our a is equivalent to 9. So let's solve for g of a. G of a, whereas a is equal to 9, so g of 9 is equivalent to 3 times 9 plus 3. We have 27, and plus 3, g of 9 is 30. Let's solve for f of a. In other words, f of 9, it's equivalent to 2 times 9 minus 2. So f of 9, so provided that 2 times 9 is 18, and 18 minus 2 is 16, f of 9 is 16. And we combine that. The operation says addition. Therefore, 30 plus 16, our answer is 46. So this is our final answer. It looks very long, but what we just have to know is that these are all the same, but they're in a different form. Nevertheless, the same value. So please do not be confused. Alright, let's move to number 4. Alright, we're given x is equivalent to negative 1. And we can apply distributive property. Let's just make this pen smaller in width. So x is equivalent to negative 1. This will be g of negative 1 minus h of negative 1. So g of x such that x is equivalent to negative 1 is equivalent to 4 times negative 1 plus 3. G of negative 1 is equivalent to negative 4 plus 3, we get negative 1. For finding h of x or h of negative 1, they're just the same. Negative 1 parenthesis, open close parenthesis, negative 1 raised to 3. Please be careful. I've mentioned this in the previous videos that negative 1 raised to a particular exponent, for example 2, is negative 1. But when you place a parenthesis, there's a difference. This is positive 1. So this kind of situation can be applied. So please, whenever there's a negative sign, it's really best, it's really a wise decision to place a parenthesis, so that the calculator, in case you place the expression in the calculator wouldn't misinterpret the what's being asked to solve. So yeah, back to the topic. H of negative 1 is equivalent to negative 1 raised to 3 minus 2 times x, which is negative 1 raised to 2. Alright, let's magnify this part. H of negative 1 is equivalent to, so negative 1 times negative 1 times negative 1, we still get negative 1. Minus 2, so negative 1 times negative 1 is positive 1, times negative 2 is still negative 2. So h of negative 1 is negative 3. And so negative 1 minus negative 3, it's, in other words, negative 1 plus 3, since minus negative is, in other words, plus, so our answer is 2. That's our final answer. By the way, I forgot to place this in number 2, just to make it just to differentiate our solution and our final answer. Final answer will be highlighted in gray. Let's move to number 5. So find g minus f, 3 times the quantity g minus f. So distributive property. In other words, what we're trying to find is g of 3 minus f of 3, such that x is equivalent to 3. So g of x, in other words, g of 3, is equal to 3 plus 3, since it says here x plus 3. And for f of x, it's equivalent to negative. So this is a negative sign by default. We don't include that. We don't have a negative sign in our initial value of x. So in other words, when we substitute, by default, we can see that because of the negative 3, positive 3 will be negative 3. Then the list goes on. We have plus 4 after, right after. Alright, let's solve for g of 3. By the way, I forgot to substitute 3 with x. X with 3. There you go. G of 3 is 6. F of 3 is negative 3 plus 4. We have positive 1. So, our operation here, it's made clear that we have to subtract. So, basically, g of 3 minus f of 3 is, in other words, 6 minus 1. So, 6 minus 1 is 5. Let's place it here. It's equivalent to 5. That's our final answer. Why am I boxing this in a weird way? Why I'm not just copying this in a different space? Well, right now we don't have much space in this paper, as you can see. But because of the highlighter, I think it does make a difference. You can easily identify the final answer. So yeah. Alright, here it's made clear that our operation is addition. And our x is equivalent to 5. Now, to solve for g of x, in other words, it could be said now that g of x is equivalent to g of 5. It's negative 4 times positive 5 plus 1. G of 5 is equivalent to negative 20 plus 1, which is negative 19. Now, for h of x, such that x is equal to 5, so h of 5 is equivalent to negative 2 times positive 5 minus 1. So h of 5 is equivalent to negative 11. And so we know that our operation is addition. Therefore, we'll add negative 19 plus, place a parenthesis to keep a distinction, not confuse the operations and symbols of integers. Negative 19 plus negative 11, our answer is negative 30. So this is weird. So yeah, this is straight to the point. Negative 30. This is weird. Pencil has been acting up these days, but so far it's still good. Let's move to number 7. So distributive property, so that we could reduce confusion. So g of 0 minus f of 0, such that 0 is equivalent to x. Alright, let's find g of x. So g of 0, the same, is equivalent to 0 raised to 2 plus 2. Given a constant that is 0 and an exponent that is not 0, rather positive, like positive 2 here, the answer still remains the same as 0. But given this, we still have plus 2, so g of 0 is equivalent to positive 2. Let's solve for f of 0, or f of x. We have 2x, so 2 times 0 plus 5. Anything multiplied with 0 is 0. Then we add 5, provided in this situation. F of 0 is equivalent to 5. And we know that our operation, we acknowledge that operation is subtraction. So g of 0 minus f of 0, in other words, 2 minus 5 is negative 3. So let's move here. Our answer is negative 3. And we'll square that. There you go. Don't forget, highlight, make a distinction. Alright, Let's move to number 8. So we acknowledge that our operation is multiplication and our x is equivalent to 2. So we have g of x. So in other words, we have to solve for g of 2. It's equivalent to 3 times 2 plus 1. G of 2 is equivalent to 6 plus 1, which is 7. And for solving f of x, in other words, we're solving for f of 2. It's equivalent to 2 raised to 3 plus 3 times 2 raised to 2. So f of 2, 2 times 2 times 2, 2 times 2 is 4, times 2 is 8. So 8 plus 3 times 4, 2 raised to 2 is 4. So 12 plus 8 is 20. Remove that. Alright, 1 crisp positive 20. Now the operation says multiply. So 7 times 20 is 140. So we'll just place that way. Alright. Then highlighter, there you go. Let's move to number 9. So for g sub 1 plus h sub 1, we acknowledge that the operation is addition and our t is equivalent to 1. Let's solve for g of t. So g of 1 is equivalent to 1 minus 3. It's already obvious. You can now say that g of 1 is equal to negative 2. Now for h of t, h of 1 is equivalent to negative 3 times 1 raised to 3 plus 6 times 1. So h of 1 is equivalent to so 1 times 1 times 1, there's no difference because the operation is still positive. So we still have 1, nothing changes, and times negative 3, we have negative 3. Then 6 times 1 is still 6. And negative 3 plus 6 is positive 3. We acknowledge that our operation is addition. Therefore, it is negative 2 plus positive 3. In other words, 3 minus 2. So we have 1. Alright, let's move to number 10. So, distributive property again. We're trying to find it. What we're trying to find is f of negative 8 plus g of negative 8. Whereas our n is equivalent to negative 8. So let's solve for f of n. F of negative 8 is equivalent to negative 8, negative 5. F of negative 8 is equivalent to negative 13. And for g of n, g of negative 8 is equivalent to 4 times negative 8 plus 2. So g of negative 8 is equivalent to so negative 32 plus 2, negative 30. Oops. Alright, encircle those. Our operation is addition. So negative 13 plus negative 30. Our answer is negative 43. Alright, and place highlight there and highlight here. There you go. Let's find, let's solve number 11. Alright, we acknowledge that our operation is multiplication. Maybe we won't have to use distributive property anymore. Let's try not to get confused, even though we're not trying to simplify this factored given that we're called to find. So let's just acknowledge that t is equal to 5, and let's solve for h of t. So h of 5 is equivalent to 5 plus 5. 5 plus 5 is 10. Let's solve for g of t. G of 5 is equivalent to 3 times 5, 15, minus 5, 10. Alright. So in other words, I won't be writing it anymore. I'll just say it now. G of 5 times, h of 5 times g of 5. So in other words, 10 times 10. 10 times 10. We'll place it here, place an equal sign, it's equal to 100. That is our final answer. Alright, let's move to number 12. Okay, we acknowledge that the operation is addition and our a is equal to negative 10. Let's solve for g of a. So g of negative 10 is equivalent to 3 times negative 10 minus 2. G of negative 10 is equivalent to negative 32. Since negative 30 minus 2, or in other words, negative 30 plus negative 2 is negative 32. And for h of negative 10 is equivalent to 4 times negative 10 minus 2, negative 40 minus 2, negative 42. Our operation is addition, so we'll be adding negative 32 plus negative 42 is negative 74. So we'll place it there. There you go. Negative 74 for number 12. I doubt. Give me a few seconds to calculate. As usual, we know the drill. Sometimes teacher doesn't know much about his solutions, but in a few seconds it can be solved under normal circumstances. Okay, g of negative 10. We acknowledge that a is equal to negative 10. It's equivalent to 3 times negative 10 minus 2, negative 30, negative 2, negative 32. For h of negative 10, 4 times negative 10 minus 2, we have negative 42. Yeah, I suppose the answer is negative 74. Yes, I can assure that the answer is negative 74. According to the answer key, it is correct and without error. Alright, let's move for number 13. Let's move to number 13. So we acknowledge the operation is division and n is equivalent to 0. Alright, let's solve for h of n. So h of 0 is equal to 2 times 0, which is 0, minus 1. We already know that it will be negative 1. Circle that. So g of n, in other words, g of 0, is equal to 3 times 0, which is 0, minus 5, so we have negative 5. Alright, division, so we divide this, so negative 1 divided by negative 5. Let's make these two negatives positive, so we have 1 over 5. That's already our answer. Most likely, the typical math teacher would prefer you to put your answer in the form of fraction, not decimal. But correct me if I'm wrong. Some teachers might also prefer the final answer that would be decimal, but everyone has their own opinions, so at least we know that the final answer could be either decimal or fraction. So that's our final take. Alright, let's move to number 14. Number 14, our operation is addition, and our x is equivalent to negative 6. G of x, or in other words, g of negative 6 is equal to negative 6 raised to 2 minus 2. G of negative 6 is equal to, so negative 6 times negative 6, just like positive 6 times positive 6, we get we get positive 36. Then minus 2, we have 34. And for h of x, so h of negative 6 is equal to 2 times negative 6 plus 5. So negative 12 plus 5, we have negative 7. So our operation is addition. So our operation is addition, but we have a negative 7. So we have a negative number which comes at a second. So I hope you get what I mean. I'll just write it. 34 plus negative 7. The addition sign becomes worthless because, in other words, our solution could be translated as 34 minus 7 instead. So in that case, 34 minus 7, our answer is 27. Okay, let's move to number 15. So, provided that we have a fraction this time, so let's simplify that. Let's not cause any confusion. In the following problems, we won't be simplifying anymore. But now, please pay toleration. Please pay attention. So yeah, this is going to be a little tricky. But basically, the technique is allocate 7 on the numerator and the denominator. So f of 7 over g of 7. That's it. So, provided that, it's also acknowledge a is equivalent to 7. And f of a, so in other words, f of 7 is equivalent to negative 2 times 7 minus 4. So f of 7 is equivalent to, further, negative 14 minus 4, negative 18. And for g of a, g of 7 is equivalent to 7 raised to 2, which is 49, plus 3, so 50, 51, 52. With that, we know that our operation is negative, divide. You can see that the fraction, usually fraction pertains to division. So numerator divided by the denominator. So, oops. Let's place here, so negative 18 over 52 is negative 9 over 26. Please, even with this lesson, I think it is imperative to use the calculator, or if not imperative, optional. If it's optional, I prefer that you use the calculator. It's going to be, I'm not sure the reason, I'm not sure about the reason why we need the calculator for this lesson, but in my hypothesis, I think I think we need to use a calculator because the computations are a little as if above sea level. It's a little beyond our capabilities, our mental thinking, our manual solving. So we only have like around 1 hour to take our exam. So we're going to encounter a myriad of problems. So the calculator would be a head start, and it's going to aid us throughout problems that only the average mind can think. So, without further ado, let's move to number 17. Number 16. Distributive property. Let's not do that anymore. Let's save space. So, we don't know this time what n is. So, n is n. Therefore, we'll just acknowledge the equations as is. And so, yeah, let's just, for one last time, let's apply distributive property. So g of n minus h of n. So in that case, let's put our solution according to the given. So g of n, what do we have in g of n? N raised to 2 minus 3. Then we have a general minus sign over there, and we'll just place a parenthesis for safekeeping. So minus h of n. So h of n is 2n minus 3. So let's further solve that. N raised to 2 minus 2n minus 3 plus 3, since this one is going to be plus This will be 0, so n raised to 2 minus 2, and that is our final answer actually. So let's move it here. Remove that arrowhead. Make this a little bigger. There you go. So that's our final answer. There you go. Alright, let's move to number 17. So still we don't know what our x value is. X is still equal to x. And yeah, the same drill. Maybe let's not apply distributive property anymore. Let's place in mind so negative x raised to 3 minus 2. Our operation, acknowledge that we have a minus sign. So minus the quantity h of x, which is for x only. So negative x raised to 3 minus 4x minus 2. This is our final answer now. This is our final answer. Move this below. So let's place an arrow. This is our final answer. And yeah, keep it tight. Place an equal sign there. There, clean. Place a highlighter. So alright. Let's move to number 18. Alright, the same drill. So g of x, 2x minus 3. Operation is minus, so minus the quantity h of x, which is x raised to 3 minus 2x raised to 2 plus 2x. The effect of the negative sign outside the parenthesis changes, or it reverses the operation of every term within the parenthesis. So positive will be negative x raised to 3, then negative 2x raised to 2 will be positive 2x raised to 2, and positive 2x will be negative 2x. In that case, okay, simplify. So negative x raised to 3 plus 2x raised to 2. 2x minus 2x is 0. So we'll cancel these. I'm so sorry. We'll cancel these two out. So it'll be gone. Even including that negative sign. So we have this. We've written that already. So we only have negative 3. So enumerate negative 3. This is our final answer. I'm sorry. Give me a few seconds to reconsider again. Number 18. Number 18. Alright, I can say that this is still correct. Yeah, there's no mistake. I just wanted to verify. I don't want to repeat the entire video just because of one mistake. So yeah, even for your safekeeping, I'm assuming that you, the watcher, are taking down notes about this exercise. You're answering along with me. So yeah, I don't want to cause a hassle. Alright, it's correct. Let's move to number 19. Number 19, distributive property. We don't have to do that anymore. Just consider these. So f of x, negative 3x plus 2 minus. So because we have an operation of negative or minus, in other words, minus the quantity g of x, which is x raised to 2 plus 5x. So negative 3x. Let's just prioritize the squared first. It's the value that comes first, according to some math rule that I've encountered before. So negative x raised to 2 minus 5x minus 3x, we have negative 8x and plus 2. I think that's going to be the final answer. Yes, I suppose so. Nothing else to simplify, and we're not supposed to factor. Factoring is optional, as I said in the previous video regarding this lesson about functions. It's optional, but I suggest you don't do it anymore. Not everything that's simplified can be factored further. math considers a few problems, but math considers a few answers factorized in this case, but not not all the time. Just leave your answer simplified. That's everything that you have to do. Nothing more, nothing less. So number 20, t is still equal to t. So um, follow along. G of t, which is t minus 4, then acknowledge that our operation is multiplication. So most probably this is going to be quadratics. Left alone, we have another term here, which is either a constant or with it a variable. Um, but it's unlikely. We only have 2t for h of t, so most likely this is going to be a distributive property, sort of simplifying. So with that, uh, just as the prophecy said, distributive property. So 2t raised to 2 minus 8t. I suppose that is the final answer. Yes, indeed. I almost forgot. You have to move this at the bottom. There you go. And place an equal sign. Alright. Let's move to number 21. So acknowledge that our operation is multiplication this time. Still the same as the previous problem that we've had. Consider that x is equivalent to still x. We don't know a constant value of it. So g of x times h of x. So 4x plus 5 times x raised to 2 plus 5x. That's it. That's everything that we have to do. So this time we have this is not distributive property, but two terms. We multiply two terms with two terms also. So we'll be using FOL method. 4x raised to 3 plus 20x raised to 2 plus 5x raised to 2 plus 25x. I think everything that we have to simplify left is the x raised to 2 terms. So 20 plus 5, 25. Whoops, I think relax space. Let's just move this to the other side. And so is the following solution. Then, yeah, move it here. There you go. Alright, we're almost finished. One last problem, I suppose. Then we can make a resolution to this video. 4x raised to 3 plus 25x plus 25x, correct. So still, for the last problem, I can't believe it's still multiplication, but it's still multiplication, whatever happens. Can't change that. It's beyond our ability. G of t, so negative 2t raised to 2 minus 5t times the quantity t plus 5, which is the h of t. So again, FOIL method. Negative 2t raised to 3 minus 10 raised to 2 10t raised to 2 minus 5t raised to 2 minus 25t. Alright, negative 2t raised to 3. Simplify the t raised to 2. So negative 15t raised to 2 minus 25t. And this is our final answer. Yeah, yes indeed, that's our final answer. Alright, I almost forgot gray highlighter there. Okay, let's check. I have the answer key of this worksheet beside me. So come along, let's check. Let's do something fun. Let's start from number 22. So negative 2t raised to 3 minus 15t minus 25t, correct. This is, I won't be dictating it anymore. It's really redundant I suppose. So that's correct. 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 Negative 2 and positive n minus 2n, correct. Negative 9 over 26, correct. 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 Negative 74, positive 27, correct. Negative 43, 1, correct. Negative 3, correct. Positive 5, 46, 82, this is 20, this is 2, negative 30, positive 140. Yeah, so I suppose everything in this solution paper is correct. So we have 22 out of 22. Hooray. So I'll be scrolling down slowly so that you can also this can also serve as your answer key so that you can review by your own after this video. Right, let's move. There you go. Right, that's the end of the video. Thanks for watching.